For my conic section project, I have chosen an ellipse to present. These are the real-life ellipses I have chosen. This one is a watermelon. There's a football. Then there's a planet orbiting. This one shows the two specific points of the foci. And then chose a hoop earring. Nissan car key. And a mirror. To get into graphing an ellipse or finding an equation, first it is important to realize what it is. A conic is from the word cone, so it pretty much is a circular cone. A cone consists of two parts that are called the naps, which intersect at the vertex. These are the naps, an upper one and a lower one. This photo displays all conic sections. The third one is an ellipse, which I will be discussing. The textbook defines an ellipse as the collection of all points in a plane, the sum of whose distance from two fixed points called the foci is a constant. The textbook also explains other major points. The line containing the foci is called the major axis. The midpoint of the line segment joining the foci is the center. The line through the center and perpendicular to the major axis is the minor axis. The 2 points of intersection of the ellipse and the major axis are the vertices, V1 and V2 of the ellipse. The distance from one vertex to the other is the length of the major axis. For my first equation to show an ellipse, I chose 9x squared plus 4y squared equals 36. To write this equation in standard form, which is x squared over a squared plus y squared over b squared equals 1, I divided both sides of the equation by 36, getting x squared over 4 plus y squared over 9 equals 1, which can also be written as x squared over 2 squared plus y squared over 3 squared equals 1. To find a to equal 2 and b to equal 3. You can find the center of this to be 0, 0, which makes h equals 0 and k equals 0, due to x and y not being added to another number in the equation. To continue to find the vertices, I found the x and y intercepts to do this. I made y equals 0 to find the left and right vertices, which resulted in x squared equals 4, and after this square root, you get plus or minus 2. So the left co-vertex would be negative 2, 0, and the right co-vertex would be 2, 0. To find the upper and lower vertices, I then made x equals 0, so y squared equals 9. After the square root would be plus or minus 3, so the vertex 1 would be 0, 3, and vertex 2 would be 0, negative 3. The last thing to do before you graph is to find the foci. To do this, you would use the equation c squared equals a squared minus b squared and plug a and b in. As mentioned before, a is 2 and b is 3. So c squared equals 2 squared minus 3 squared, which is c squared equals 4 minus 9, or c squared equals 5. And after the square root, it would be c equals plus or minus square root of 5. So the focus 1 is 0, square root of 5, and focus 2 is 0, negative square root of 5. Finally, you graph. So you plot the origin, 0, 0, then f1, which is 0, square root of 5, or 0, 2.24. And then you do f2, 0, negative square root of 5, or 0, negative 2.24. Then you would plot all the vertices. So v1, 0, 3, v2, 0, negative 3, the left co-vertex, negative 2, 0, and the right co-vertex, 2, 0. In this particular ellipse, the minor axis is the x and the major axis is the y. For my second equation, it was to find the equation of the ellipse whose foci are at -1, 0, and 3, 0. The length of its minor axis is 2. To recall, the center of the ellipse is the midpoint of the foci, which when placed on a graph is in between -1, 0, and 3, 0. The center would be 1, 0. To find C, it would be the length from one foci to the center, so C equals 2. The length of its minor axis is 2, which is 2 equals 2b, so b equals 1. Then you would take a squared equals b squared plus c squared to find a squared, since you have all points but a. H equals 1, k equals 0, and b equals 1. You would set a squared to 1 squared plus 2 squared, which is 1 plus 4, or 5, which after the square root is still the square root of 5. You can then plug in the equation. Since b is 1 and k is 0, it will be y squared plus x minus h, which is 1. So y squared plus x minus 1 squared over 5, which is a squared, equals 1. To find the major axis length, it would be 2 multiplied by a, so 2 times the square root of 5. Then you would find the vertices, so when an ellipse is parallel to the x-axis, such as this one, you would find the vertices at h plus a, k, and h minus a, k. So 1 plus square root of 5, 0, and 1 minus square root of 5, 0, or 3.24, 0, and -1.24, 0. The co-vertices are on the same line, and in this case vertical to the center, so 1, -1, and 1, 1. Now we graph, plotting V1 at -1.24, 0, and V2 at 3.24, 0. Then the foci which are given, so -1, 0, and 3, 0. And you would graph the co-vertices at 1, -1, and 1, 1. In this case, the major axis would be the x-axis and the minor would be the y. For my academic plans, up until recently, I have wanted to be a pharmacist until I realized that speech-language pathology is my passion. After graduating high school and getting my associate's degree here in the next year, I plan on applying to USF to pursue my bachelor's and master's degrees.